Alright, another Thunderfoot type video. It's kind of weird though. All his really highly viewed videos are all like a year or two old. So he hasn't been breaking into those kind of numbers in quite a while. So here at number, I guess it is 7. Nitrogen. Yay, nitrogen. So he's got 405,000 views. 400. Yeah, I said that right. Yeah, I said it right. I know I did. Anyway, I'll load that up while I talk about nitrogen. Yay, nitrogen. Um, yeah, it does a lot of neat stuff, nitrogen. Um, I mean, it's a big part of the whole living thing kind of stuff. It's like the seventh or eighth most abundant element in the universe. Um, Explosives. Yeah, that's first kind of comes to mind. I mean, it's like really good at creating compounds that can release their energy very quickly. So it does the nitrogen oxygen thing, happens a lot. Nitric oxide and stuff. Make your brain a little crazy. Yeah, your brain really can't. It doesn't know nitrogen exists, so it kind of gets fooled by it. It can actually think nitrogen is oxygen, and you can suffocate in an environment of nitrogen. You won't even know you're suffocating. But anyway, yeah. So I mean, I don't know all the dynamics of it, but yeah, I don't know exactly how it shapes itself or why it's so, um, you know, it's some sort of acidy kind of thing or something. It just does that oxidizing thing, which makes oxygen is very good for anything that's trying to catch fire or explode. So yeah, nitrogen just facilitates a lot of that. Good catalyst again, another catalyst kind of word. Can't be calling everything a catalyst, but nitrogen does seem to fit in that category. The liquid nitrogen thing is kind of neat. So it can be in a. I guess it could be in a solid. I really don't know. I never saw solid nitrogen, but anyway, definitely liquid gas thing. And obviously, to create the liquid, you have to, you have to freeze it. I mean, you have to cool the atmosphere really cold, and then the nitrogen will turn into a liquid, and you can get pure nitrogen that way, I think. Well, anyway, but it takes it a while to boil. So I mean, if you put it in a container, it's like water. Like you put water in a fire if you have the water in a thermos, and it'll take a while for the water to evaporate. Well, nitrogen just does that at a different temperature. So, yeah, I mean, at room temperature, if you spread it out, it's going to turn into a gas. But, if you keep it in a container, it'll last quite a while as a liquid. It'll just sit there as a liquid. And so most of the time you see it in these thermosy things that people are putting liquid, things into the liquid nitrogen. But yeah, it's basically, it'll stay a liquid for quite a while as long as you have it in a container where only because the air isn't a very good conductor of heat, and it especially isn't a good conductor going down into something. Heat rises, so the liquid nitrogen basically creates a layer of mist above it, and so the heat can't really get to it as long as you have it in a vacuum sealed thermos. So anyway, I mean that's more than you need to know. But I mean, obviously, it's really, really cold though. Once you get into that liquid state, it stays in that liquid state. Um, and yeah, it's not very thermally conductive or whatever the term would be. So the atmosphere can sit on top of it and it won't immediately evaporate. But obviously, you drop things into it, it'll start boiling because it's like dropping a hot something into water. If you drop a really hot thing into water, the water will start boiling around the hot thing, and the same thing happens with liquid nitrogen. Well, that was a lot more than we needed. All right, sorry about that. So anyway, moving on.
I'm going to give you the
Ooh,
order of
Hoven
events that I
guy.
think happened, and then go back and kind of review each of them just a little bit to try to put it into perspective of what happened.
I'm in jail now, and
Noah
I've really
and the
come to
animals
know
went safely onto the ark.
homosexuality, and I think I love it.
God shut the door, sealed them in. I think a 300 below zero Fahrenheit ice meteor came flying through the solar system and began to break apart. Fragments of this meteor hit the planets and caused the craters on the moon and other planets. And a bunch of it came and made the rings around the other planets.
Look
Saturn,
at that,
and
he
Uranus,
has a
and
whole
Neptune all have
theory.
ice rings around them. And some of the fragments of this meteor hit the Earth. landing on mostly the north.
A meteor? No, it have to be bigger than that. Anyway, whatever. It is kind of funny. Noah and the animals were safely in the ark at the time. Thank goodness.
South Pole, freezing the mammoths standing up. As this meteor came flying in and breaking apart in space, the fragments would tend to be dumped largely around the poles because of the Earth's magnetic field. So the Earth had these massive cold spots.
Massive cold spots.
Yeah, that's pretty
in
funny.
order to understand why this is bullshit, it's necessary to understand the general orders of magnitude of the solar system.
No, I don't think so.
The Earth is a
No, you don't need to know all that crap. You really don't. But anyway, go ahead.
gravitational well.
Go ahead.
In order to escape from that well, it's necessary to have a certain amount of energy. This is usually expressed as an escape velocity, the speed at which you need to throw an unpowered object for it to escape from the gravitational well of the Earth. For the Earth, this is about 10 kilometers per second. This is also the velocity that an object falling from infinity to the Earth's surface will gain. So if an object falls from infinity to the Earth's surface, it'll hit it at about 10 kilometers per second. However, the Earth is only a bit player in the gravitational profile of the solar system.
Yes, okay. So all this to explain that there's poles on Earth, and that, you know, that's why, I mean, the poles are further from the sun. Jeez. I mean, that's why the ice is on them, because they're further from the sun.
Shown in black is the potential felt by a unit mass in the solar system, while in red is shown how much of this potential is due to the sun. If we zoom out, we find that it takes much more energy to escape from the sun than from the Earth.
Very important.
Similarly, an object falling into the solar system, such as the comet the creationist mentions, will gain a lot of energy.
Well, he actually said meteor, so, you know, you're giving him credit by saying comet.
Turns out, an object falling into the sun's gravitational well will be travelling at about 30 kilometers per second by the time it reaches the Earth, which is also about the orbital velocity of the Earth. So let's take a unit mass and collide it with the Earth at cometary speed.
Well, a unit mass, so you're just going to make up numbers now, so that really doesn't going to work. It could have been a very small comet. And maybe it bounced, you know. And maybe it hit just at the right angle and hooked into the atmosphere. It depends on, you know, the angle of inclination or whatever that you're flying at. You know what I'm saying? If you could re-enter the Earth's atmosphere really at a harsh angle, and you'll get hot as hell. Or like the space shuttle, you can try to do it really slow, and that way disperse the heat. Yeah.
It turns out that enough energy is released to raise the heat of that unit mass by 10,000 degrees Celsius. Now, when you're talking about raising the temperature of an object by 10,000 degrees Celsius...
Yeah, but you won't do that if, like I said, you come in at an angle.
It really doesn't matter if you start from absolute zero, that's about 300 degrees below freezing, or if you're working in Celsius or Fahrenheit. The one thing that's absolutely certain is such an impact wouldn't freeze the mammoths where they stood, it would vaporize them.
Well, again, I don't think he said the damn thing landed on a mammoth. I think you know it got squished if it landed on him. His argument is that some sort of, like, wave of froziation, you know, the wave of froziation came off of the comet and froze the mammoth. But what's the difference? I mean, he's talking such utter bullshit that, you know, what? It's like Dr. Freeze or something. I mean, it's like telling a Batman story. I mean, it's just so nutty that why even argue with it? Just say, God, you're fucking stupid. I mean, this is your Hovind theory of kookology? Come on.
This is the amount of energy that would be released by such an impact. This girl sits in a cubic meter. A cubic meter of water weighs about a ton. Recently, the Deep Impact Probe dropped an impactor weighing about a third of a ton into the comet. The impactor struck the comet at about 10 kilometers per second and released the equivalent energy of about 4.5 tons of TNT. Now, for cubic...
Yeah, wow. 4.5 tons, so that's like 1/1,000,000th of a nuclear bomb.
meter of water hits the Earth at cometary speed, 30 kilometers per second. That will release enough energy to raise the temperature of that water to 10,000 degrees Celsius. That's an equivalent release of energy to 100 tons of TNT.
To be dumped largely around the poles.
Yeah, well, 100 tons is still not. You still haven't gotten close to a nuclear bomb, right? So we know the planet Earth isn't going to blow into a million pieces because you drop a nuke on it. You got to drop more than one.
Because of the Earth's magnetic field. So the Earth had these massive cold spots.
We've already shown that the massive cold spots would be about 10,000 degrees Celsius. But let's now say the comet...
Yeah, well, see, that's garbage, though. Well, I mean, whatever. I mean, obviously, if a comet hits, it's going to get cold because it's going to knock a whole bunch of crap into the atmosphere. So at first, it's going to get really cold because a lot of sun's radiation is going to get reflected back into space, and so in the short term, it's going to get really, really cold.
Size here was a mere 200 by 200 by 200 kilometers, much smaller than that shown in our creationist animation. How much energy would such an impact release? It's difficult to convey such numbers in a meaningful fashion. This is about a...
I mean, a 200-mile, I mean, kilometer, no, well, 100-mile asteroid. It's 100 miles is a pretty big rock.
4 megaton thermonuclear device. A 200 by 200 by 200 kilometer ice ball colliding with the Earth at cometary speed would release the equivalent energy of 30 such nuclear devices for each of the 6 billion people who currently live on this planet. It doesn't make any difference if the comet arrives in one piece or as fragments. It will still deliver exactly the same amount of energy. That's 4 megaton devices.
Yeah, but how it delivers it really does matter. Is how it delivers it. So it could deliver it dissipated over time, by heating the atmosphere, or it can go straight in for the kill.
For each of the 6 billion people who currently live on the planet. If Noah really was on that ark, water would have been the least of his problems.
I think that was actually an exaggeration. That picture there, that I think is an exaggeration. Yeah, I do. I believe that's an exaggeration. That's not 20 nuclear bombs. I mean, that's a lot more than 20 nuclear bombs there. Or did you say 40? Well, it's still more than that. I mean, 40 nuclear bombs, you go, be like a little blip, little blip, little tiny pimple. This is a big, giant, goddamn fucking pustule there. That's a real wound. I think so. I think you're full of shit, too. Anyway, moving on. Health and respect are traveling at cometary speed. Commentary. That's funny, commentary.
Fragments of this meteor hit the planets, landing on mostly the North and South Pole, freezing the mammoths standing up.
Yeah, that's a fun. I mean, right there. I mean, freezing the mammoth standing up. I mean, I don't know how many people. I mean, realistically, if I took that on the streets, I mean, as dumb as people are, I mean, most people are going to be like, "What do you mean?" I mean, we can't even make no Mr. Froze a ray or something. It's going to freeze something standing up. I mean, that's kind of nutty. I mean, unless you're going to like spill liquid nitrogen on us or something, that's not going to work, right? I mean, when you need like liquid nitrogen or something. Yeah, that's the other thing with liquid nitrogen. You know, it's if you're not wearing clothes, you're safer because it's really how it needs some sort of if it gets right on your skin, it's almost like the boiling water effect. I mean, if you throw water on a hot pan and the way it like sizzles, and it takes a while for the water to evaporate because it sits on a layer of steam. Well, I guess the same thing happens with liquid nitrogen. So you can sort of spill the liquid on yourself, and it won't do too much damage. But if you're wearing something like clothes, then you're really fucked. Then you're gonna get frozen, and your arm will fall off and such. That's a little extra added on thing. So it is kind of nice though that nitrogen and cold is both the subjects and such, so that's sort of good. And there was a little bit funny, so it's kind of like laughing gas. So that's nitrogen again, so that was good. Let's see if there's a comment here. Let's see. Exactly. That's why you need to watch Thunderfoot explain. No, I didn't need that at all. So he was answering somebody else's comment. A simple test of this wacky hypothesis would be to see if all the craters on the moon are of the same age. Yeah, well, I don't know. You know, I'm just trying to think how exactly you do that. I mean, you can see they fall on top of each other, but yeah, the dust wouldn't settle, so they'd all have the same amount of dust settled on top of them. That would be the key thing. They wouldn't have, some wouldn't be faded or more than others. They'd all have the same fade rate, and they obviously don't have the same fade rate. Some are much more eroded. I mean, there's no erosion on the moon. The erosion takes place because new impacts cover the old impacts. Yeah, boy, I was pretty smart. Yeah. Anyway, probably enough of a video, but yeah, I mean, that was really terrible. I mean, it wasn't terrible. I mean, just saying, wasn't that way more science than you needed to laugh at frozen mammoths while they're standing up? I mean, it just is just crazy talk. I mean, even Pompeii, people were running away. I mean, they weren't like frozen standing up. They were covered as they suffocated on the ground. You know, I mean, you know, freezing a mammoth when he's standing up, that's just nutty. I mean, it's insulated, so it ain't gonna freeze anyway. It's gonna take a while to freeze a mammoth, unless you pour liquid nitrogen on. Then it's easy because the hair will trap the liquid nitrogen and pull the warmth right out of you. Yeah, because see, the nitrogen will evaporate really, really quick. So it's like condensation. You know, that quick evaporation creates condensation. What's the word for that? That cooling effect, like air conditioners. You know, but it'll happen real quick when the nitrogen can spread out through some kind of fabric or material. Yeah, so it just pulls all the heat out really quick. So it's a quick reaction. Nitrogen creates quick reactions. Helps facilitate them, such, so forth. It makes nuclear bombs too. Well, it doesn't really make it. No, it doesn't have anything to do with nuclear bombs. No, it's nitroglycerin, gunpowder, you know, that kind of stuff. Anyway, till next time. Such, so forth. Oh, you got that neutron? No, yeah, no, hydrogen. Yeah. Never mind. Till next time. And such. Actually, they do. I think they use nitrogen. Yeah, they create a really good explosive to do the, you know, when the atomic bomb blows up, what basically happens is they do that implosion thing. So they put a bunch of bombs around in a circle and then force the fissionable materials together. And that's what makes the rebound explosion take place. So the initial explosion in a nuclear bomb is nitrogen explosion, is a regular ballistic explosion, not ballistic. Yeah, well, whatever. You know, regular chemical explosion. Yeah, that's the word I was looking for. That initiates the nuclear reaction. Alright, now this is way all this extra. Fuck this extra shit. You know, nobody needs extra. Yeah, hell with that. Alright, anyway, till next time. Nitrogen.